So last time we covered the basics of graphing, so the definitions, what'll help you actually move into graphing functions. Today we're just going to focus on the sine function, and then we'll do cosine tomorrow. So our sine function, remember that sine functions are related to the unit circle. It's the y-coordinate from the unit circle. So in order to graph our sine functions, we're going to need those ordered pairs from the unit circle. So we still need an xy axis. The only difference here is that on the x-axis, remember that the x-coordinates are in radians. And that the y-coordinates are the coordinates from the unit circle. So I'm just going to use 4 points from the unit circle, the main ones that are pretty easy to graph. So those I think they're called quadrilateral angles. So your 0, pi over 2, pi, 3 pi over 2, and then 2 pi. So the first thing we're going to do is divide up our x-axis into those points. So if we say, all right, here's 0, so then we'll call this pi over 2. That makes this pi, 3 pi over 2, and 2 pi. Now this doesn't need to be perfect, it's just a sketch. Okay. Now we're going to go ahead and graph those functions. So sine of x. So if our first pair, the x-coordinate is 0, then the y-coordinate is the y-coordinate from the unit circle. So 0, 0 is our first point. At pi over 2, our y-coordinate is 1, so pi over 2 and 1. At pi, our y-coordinate is 0, so we're back on the x-axis. At 3 pi over 2, the y-coordinate is negative 1. And then at 2 pi, we're back at 0. And this is the shape that a sine function makes. And it's going to repeat in this fashion. So our domain is all reals. We can go in both directions, positive and negative. Of course, we have our, between 0 and pi over 2, you've got pi over 4, pi over 6, all those different values are in between. Our range, though, is fluctuating between negative 1, 0, and 1. So our range is between negative 1 and 1. Now you can write it in the braces, or the brackets, like we have here, or you can say that y has to be greater than or equal to negative 1 or less than or equal to 1. Either one of those will work. The period is how the horizontal distance it takes to complete one cycle, and that was 2 pi. The midline is that halfway point on the graph, so y equals 0. Remember that it's a horizontal line, so you have to write it as y equals. Amplitude was the distance from the midline to the max or to the min. So our amplitude here is 1. And the x-intercepts are going to be 0, pi, 2 pi, and it goes on from there. We could keep adding on. We could also include negative pi. We could include 3 pi, and so on. So it's going to keep going. So all of the pi values, where it's just pi, it's not a fraction, are your x-intercepts. Your y-intercepts, though, the only place it's going to cross the y-axis is at 0. And those are the key features of your sine function. So it comes from the unit circle. Now, one way that I like to remember the shape of a sine function is it makes hills and valleys, over and over again. Or you can think about it like a roller coaster. So your sine function will always start from the midline and go up. unless it's been reflected. If you notice that your graph starts at the midline and goes down, then you know it's been reflected. But we'll talk about that a little bit more next week, or sorry, at the end of this week. All right, and here's just a little bit of a better picture of it. So notice that our sine function, again, you have x-intercepts along those pi marks, and that you only have one y-intercept, and it's at 0. But you do have several x-intercepts. And again, noticing that shape forms a hill and then a valley, and it continues on in that pattern. All right, we're going to touch on transformations today, and we'll continue to talk about them this week and next week. So we sort of got started with them yesterday when we talked about the vocab, key vocab, but your A value, your vertical stretch or compression, is the amplitude. Okay, so we're not going to talk about it as a vertical stretch or compression. We're going to now talk about it as the amplitude. Again, the amplitude has to be positive. Remember that if there's a negative in front of that A, that's a whole nother transformation, and that means reflection. Across the x-axis. Okay, for the horizontal stretch or shrink, that we're now going to call, it's like the period length, but we'll talk about that in a little bit too. Your C, which normally is your horizontal shift left and right, is now going to be called the phase shift. But we won't worry about those till next week. And then D, like we talked about yesterday, is the vertical shift, and it's also the location of the midline. All right. The other thing to keep in mind is that inside is opposite, the outside is the same. So if you see a minus C, well, you might think you're moving to the left. You're actually moving to the right. Remember that the B is not going to be, if it's a whole number, it's not a stretch, it's a compression. And we'll continue to work with those as well. All right, so with this graph, what we're going to do is identify a couple of things first before we actually graph the points. So the first thing you want to do is identify your midline. Remember from the last slide that your midline is found at the end. It's that vertical shift up or down. So this is going up 5, so our midline is at y equals 5. Okay, keep in mind that, again, the midline is a line, so you need to be writing it as y equals 5, not just 5. Okay, so at 5, we're going to put a dashed line to represent our midline. Now these are just sketches, it does not have to be perfect. All right, next thing I'm going to do is mark off the amplitude. Well, the amplitude was that A value, A for amplitude, A for the A transformation, I guess you could say. So amplitude is 4. Now amplitude was the distance from the midline. So I'm going to go up 4 units and down 4 units to represent my amplitude. Okay, so I should have a point at 9 and a point at 1. Those should be my max and min values. The next thing is to scale the x-axis based on the period. Well, the period was found by the number in front of the x. Since we don't have a number there, we're going to stick with the normal sine period, which we found on the first slide was 2 pi. So just like what we did on the last slide, we're going to mark off based on pi over 2, pi, 3 pi over 2, and 2 pi. And the last thing is to sketch the graph. Remember that a sine function makes that roller coaster hill and valley shape. Normally though, our sine function crosses at the x-axis on those pi values, pi, 2 pi, 0. But remember that that's where their midline was originally. Now that the midline has been moved up 5 units, my graph is going to be crossing the midline at 5 at 0, pi, and 2 pi. So at that pi over 2 mark, it's not going to be at 1 like it was on the last graph. It's going to be at 9, because that's our maximum. We come first and make a maximum, then we cross in the middle and come down to our minimum, which was 1. And you can even keep going from here. So if you wanted to make, next up would be 5 pi over 2. So if you wanted to mark off another maximum at 9, you could keep going. Okay, now again, we're just doing a quick sketch. So normally what I'll ask you to do is to graph either 1 period or 2. So remember, 1 period was the distance it took to complete 1 cycle. So going to 2 pi would be 1 period, or 1 cycle. But you also, if I asked you to go to do 2 periods, then you'd want to go out to 4 pi. So you just continue the pattern as we've been doing. Okay, so let's take a look at one where the period does change. Now, there's a trick for that one, and it's this formula here. You can find the period by doing 2 pi divided by b. And remember that b is that number in front of the x. So like last time, the first thing we're going to start with is drawing the midline. Well, where's our midline? It's whatever you're adding or subtracting to the end. So since we're not adding or subtracting anything on the end, our midline is going to be at 0. Next up would be the amplitude. Amplitude is the number in front, so 2. All right, next thing is to scale the x-axis based on the period. Well, here's where that formula comes in. So we know that the period is equal to 2 pi divided by b. Well, b in this case is 1/2. Now remember back to when we were evaluating trig functions, or really a lot of different things we've done in algebra so far. If you have a whole number divided by a fraction, you need to use that keep, change, flip. So we have 2 pi, change to multiplication, flip the 1/2 as 2 over 1. So our period is actually 4 pi. So that means we're stretching it out. I'm going to complete 1 full cycle in 4 pi instead of 2 pi. So this time it might actually be easier to mark it off in terms of pi. Okay, so keep in mind again that the shape of a sine graph goes up, down, and back up. So I'm going to be starting at my midline at 0. And 4 pi is where I'm going to end up back at 0. Halfway between I'm at 0, so at 2 pi. And then my max is halfway between the first 2 points, and my maximum was at 2. So at pi, I have a point at 2. At 3 pi, I should have a point at -2. And you can connect the points from there. Okay, so your first point should always be at the midline, your middle point's at the midline, your final point's at the midline, and then you have a max and a min at the other 2 halfway points. All right, guys, I'd encourage you to take a second, pause the video, see if you can try to graph this function. All right, hopefully some of you guys were able to pause the video and take a look, but let's go over it together. So first up is the midline. Well, I'm not adding or subtracting anything to the end, so my midline is at y equals 0. The amplitude, remember that the amplitude is always positive, so it's just the 2 in the front. So I should have points at positive 2 and negative 2. The period, there's nothing in front of the x, so it's 2 pi. Okay, so notice every time we're graphing these, we're using 4 values because we're using those 4 key values. Okay, the next thing is to sketch your graph. The only difference here is that we have a reflection. So instead of our normal up, down, and back up, we are changing this, and our graph is instead going to go down, up, and back down. We're taking the 2 humps and flipping them over the x-axis. Since our middle points are on the x-axis, they're not going to change. So we still have a point at 0, 0, at pi 0, and at 2 pi 0. The difference, though, is that my middle points, instead of the one at pi over 2 being up at positive 2, it's going to be at negative 2, and the 3 pi over 2 point will be at positive 2. So this would be our sine function, and it's been reflected. All right, so let's go ahead and put everything together. What if I gave you a bunch of different transformations? So just like last time, we'll start off by finding the midline. This time we're at negative 5. So y equals negative 5 is going to be our midline. Let me move this. All right, next up would be your amplitude, which is the number in front, so at 2. So I should have a maximum at negative 3 and a minimum at negative 7. Next up is the period. Remember that the period is equal to 2 pi divided by b. Well, our b value in this case is 4, so we're doing 2 pi divided by 4, which means the period is pi over 2. So this graph, instead of getting stretched out, is going to be smushed in like an accordion. So we have points at 0 out to pi over 2. Well, halfway between 0 and pi over 2 is pi over 4. And then we can kind of estimate the other ones from there. Now, you could go in and divide again, and you could say, okay, well, halfway between 0 and pi over 4 is pi over 8, so you can label those as well. All right, now that means, now we're ready to graph. Okay, so we don't have a negative, so the shape of our graph is going to be that hill and valley shape. So if we start at our midline and place 0, remember that halfway between is where it's going to cross the midline again, which was pi over 4, and then we should finish the graph at pi over 2. And we're going to come up to our max at negative 3. Halfway between, oh, that was not halfway between. That looks a little better. All right, so halfway between our 0 and pi over 4 mark, we're going to come up to negative 3, come back down to the midline. Halfway between pi over 2 and pi over 4, we're going to come down to our minimum at negative 7, and then come back up to pi over 2. Or back up to midline at pi over 2. All right, so when you graph sine functions, it's a lot of dividing things in half. So if you sketch out your period, divide it in half so that you know where to put the middle point of the cycle, and then half of that is where your maxes and mins should occur. All right, so hopefully that helps get you guys started. This does take practice. So I posted a couple extra practice problems for graphing sine functions. Please take a look at those and then join into our conferences if you guys have any questions.